Hi, so I'm trying something new this time. What I'm trying is I'm gonna look at a problem that I've never looked at before and solve it from scratch so I can talk through like the process that I'm thinking of, and I'll see if that's more helpful than creating an editorial in video form, which you could like look at the text editorial already for. So let's look at this problem from USACO 2018 February, gold. Let's see. Early in the morning, Farmer John woke up to the sound of splintering wood. It was the cows, and they were breaking out of the. Oh, yeah. I'm also going to time it with the stopwatch so that you know how long everything takes, especially if I edit things out. I'm just going to start that. Okay, so the cows are breaking out of the barn again. Oh no. Farmer John was sick and tired of the cows' morning breakouts, and he decided enough was enough. It was time to get tough. Oh, that rhymes. He nailed to the barn wall a counter tracking the number of days since the last breakout. So if a breakout occurred in the morning, the counter would be 0 that day. If the most recent breakout was 3 days ago, the counter would read 3. Farmer John meticulously logged the counter every day. The end of the year has come, and Farmer John is ready to do some accounting. The cows will pay, he says, but something about his log doesn't quite look right. Farmer John wants to find out how many breakouts have occurred since he started his log. However, he suspects that the cows have tampered with his log. And all he knows for sure is that on the day his log started, is that he started his log on the day of a breakout. Please help him determine the number of breakouts that might have occurred since he started the log. The minimum number of log entries that must have been tampered with. Okay, so you have n days, and you have non-negative integers, indicating what the counter is on every single day. The first, you're supposed to output the minimum number of possible breakouts, and the log entry that matches that. Okay, so I'm looking at the sample. Oh no, okay, so I read the output format wrong. Minimum number of possible breakout sequences with I breakouts. Oh, so if there's one breakout, looking at the note on the bottom, if there's only one breakout, the log would look like what they show, which is 4 entries different from the given log. If there's 2 breakouts, how many entries are different, so on and so forth. Okay, I get the problem, and it's been like 2 minutes, but I get the problem. Okay, so the first day has to be a breakout, which means that the first number has to be 0. In this sample, we'll put the first number as 1. That will not work. If there's only one breakout, then it has to look like 0, 1, 2, 3, all the way up to n minus 1. And so to solve the problem for one breakout, that's an easy O of n solution. The problem is if you have 2 breakouts. So, okay, you could try, the brute force solution would be, for each of the 100 days, we could try every day either breakout or not breakout, which is runtime of O of 2 to the 100. As in, this looks like a DP problem, because out of all the 2 to the 100 possible ways of taking cows and not taking cows, we only care what the current day is and how many days have been taken or how many days are different in the past. So that's just that there's a lot less states that we care about than the states that actually exist. So that's just an O of n cubed DP solution is what I'm thinking. So this is for every day, and we'll do each of the 100 days separately. We care about how many days in the past were already different. And in the past meaning before the current day. We also care about what the current value of the day is. And so the thing to remember is, okay, let's just say that in the sample input here, the first day is 1, right? So we don't necessarily want 1. We could put 0 in this day, we could put 2, 3, 4. And we want to store what we're putting, not what the input says. Now, of course, for the first number, it can't be 2, 3, or 4, but it can be 0. So we also want to store that. We want to store the value we're putting for the current day. And this is important because the value we're putting for the current day is either 1 plus the value for the previous day or it's 0. So now this looks like a solution of DP, the current day, and from the day we can look at what the day is supposed to be to see if it's the same or different as the value for the current day, number of different days in the past, and the value for the current day. Sorry, the screen's kind of small, but I think it'll do. And let's just double check what we're supposed to output, because I think I forgot. Okay, so if we want to have 2 breakouts, what's the minimum number of days possible? So I think that actually we should change this, because what we're trying to find, if you look at the output format, is the minimum number of different days in the past for the given number of input sequences. So we should change this. We should change this to number of breakouts. And we'll say it equals number of different days. Okay, so currently this looks like we have n cubed states. N cubed states is fine because n equals 100, so 100 cubed memory will work. For runtime, we can in fact do O of n to the 4 because we can do 500 million operations for runtime, and this is greater than 100 to the power of 4. So this means, so the runtime of a DP is number of states times number of transitions times the runtime for each transition. So for example, if it takes O of n to make one transition, then we'll multiply by n here. So this means that number of states is O of n cubed, which means that transitions times time to get transitions can only be O of n, because our runtime has to be less than or equal to O of n to the 4. How do we go from day equals I to day equals I plus 1? Assuming we've solved everything from day equals I. Let's consider dp I plus 1 jk. Actually, let's look at dp I, and let's make this that we're going from day equals I minus 1 to day equals I. Okay, so we're looking at dp I jk. How do we solve this? So let's see, we'll take a minimum of a bunch of things because we're trying to find the minimum number of different days. Okay, so we can so either we break out on the current day or we do not break out on the current day, right? This is actually, I think I got something. Okay, so if k equals 0, then we are breaking out on the current day. So if we're breaking out on the current day, then this means that the number of breakouts, which is j, has increased by 1. So if we're breaking out on the current day, then it's not then it is a minimum of a bunch of stuff. So then our answer, dpijk, equals the min. So from the previous day, 1 less breakout, because we're adding 1 to the number of breakouts. K can be anywhere from 0 up to n. K can be anywhere from 0 to n. So we would take the minimum of all those. And let me explain this a little bit. Okay, so if we're breaking out on the current day, the previous day can have any value. This is what 0 to n means. They can have any possible value. We don't care what the previous day was. J minus 1 means the previous day had 1 less breakout. I minus 1 means we're on the previous day. So that's what that means. Okay, now if k is not equal to 0, this means that we're not breaking out in the current day. And the current day is for sure not a breakout because any day that is a breakout has to be 0. So if the current day is not a breakout, then that means that dpijk equals the minimum, because you're trying to find the minimum number of differences, of dp of the previous day, the same number of breakouts, because we're not adding a breakout, and k can be anything from 0 to n. Now, again, what this means is that we're on the previous day. That's what I minus 1 means. J means the same number of breakouts, because if you recall, the second one is the number of breakouts. The third one is the value of the current day. The value of the current day can be anything from 0 to n. Oh, actually, I'm missing one thing in both of these two formulas. This could possibly be plus 1 if, I'll call this input of I is not equal to k. As in, if k is different than the input sequence. So if the input sequence here is 2 and k is 3, as in we're changing the number. If we're changing the number, then we want to add 1 to the DP value because that's one more difference. Recall the DP value equals the number of different days. So we want to add 1 if it's different. And this means that if it's different, basically. And we have to do the same thing for this DP value here. Plus 1 if input of I is not equal to k. Okay, this is not how you would type it up, obviously. This is weird syntax, but it's just pseudocode, so that's fine. Okay, let's look at the runtime of this. If k equals 0, then the runtime, then what we're looking at is this thing here. We need to take the min of n terms. So the runtime is O of n. And as you recall, we had an extra n factor for this because number of states was n cubed. So the number of transitions can also be O of n. So we can do that and the runtime will work. And the same thing occurs for if k is not equal to 0. The runtime is still only looking through n more terms, and so that also works. The same runtime. So the runtime is O of n to the 4th, and the memory is O of n cubed, so this solution will work. Okay, I'm going to start the stopwatch again. Alright, so the first thing we do when we write code is we include everything. And we use standard namespace, and we start our main. Okay, so let's look at the problem statement here. So the input is formatted in, we're given the integer n, and we're given all our input after that. So we'll have our int n, and we'll have our input up to 100 of them. Let's read that in. Okay, build that. So far so good. Yeah, okay, cool. So the next thing we need to do is I have the DP on the left here. We need to create our DP array. So the first dimension is the day. The second dimension is the number of breakouts. We could break out anywhere from 1 to 100 days. We cannot break out on 0 days because the first day must be a breakout. So I'm going to put 101 because this could reach up to 100. It could equal 100. And the last dimension is the value of the current day. The value is again from 0 to 99 because the first value has to be 0, which means all the subsequent values can only be gain 1 every day. So the max it can reach is n minus 1. And I'm just going to put a note here to myself of what this means so I don't forget. It just makes it faster when I code. Alright, cool. So now, since this equals the minimum number of changes, we need to initialize everything to infinity. So let's do that. And I'm going to put, so really here I wrote 0 to n. For k, it should really be 0 to n minus 1. J is from 1 to n, but I'm going to initialize j equals 0, just because when we refer j minus 1 in the k equals 0 situation, it doesn't give an error, or it still works. Okay, a good infinity is 10 to the power 9. It won't overflow an int, and it'll work. Because the minimum number of changes can be maximum n, which is 100. So really anything over 100 will work. But I'm using 10 to the power 9. Okay, so now we need a starting state. What do we start with? So the first day has to be a breakout, which means the first day has to be 0. So this means that DP is day 0 or the first day, which is day 0. Number of breakouts is 1. Value of the current day must be 0. It's equal to the min number of changes. So if input 0 equals 0, then we don't have to change anything. So the minimum number of changes is 0. Else, the minimum number of changes is 1, because we need to change that current day from whatever it is to 0. Okay, on day 0, there's nothing else is possible. And then we move through the rest of the days, starting at day 1, we already did day 0. I'm going to start j at 1, just so that when we access j minus 1, it doesn't give an error. And it's never possible to have j equals 0, because we start out with 1 breakout, for sure. Okay, so the first thing here in purple says if k equals 0, the current day is a breakout. Then dp ijk equals the minimum of dp I minus 1, j minus 1 from 0 to n, plus 1 if input I is not equal to k. Okay, so we'll add the 1 in later. Let's first take the minimum of all those values. So for int k2, because this is the second value that's going in the k position, see k2 starts at 0 and goes up to n minus 1, which means less than or equal to n, or less than n, the equivalent of less than or equal to n minus 1. Just going to add some space to make this a bit more readable. Oh, okay, so it's different if k equals 0 and if k is not equal to 0. So let's put this for k equals 0 first. Cool. Okay, then dp ijk equals the minimum of what it currently is, and dp I minus 1 the previous day, one less breakout in k2. And I'm just copying this from the picture on the left, so I don't have to think too much. Okay, if k is not equal to 0, the code is very similar, almost identical, except for instead of I minus 1 is j. And again, I'm just copying this from the code at the left. Oh, I forgot one thing, the plus 1. If I is not equal to k, dp ijk plus plus, and just add that here. Okay, just gonna build it to make sure everything's good. Oh, we did k plus plus here. Alright, cool. Now what we need to do is we need to get the output. So what we're supposed to print, the minimum number of possible breakouts, minimum number of differences for each number of breakouts, and this is written really badly. But basically, we're supposed to put div dp for dp n minus 1, we have to put the minimum of j, for j, the number of breakouts. For every single j, from j equals 1, j equals to n, and day equals n minus 1. On the last day, so you have to go through all the days. For all of these values, we have to print the minimum for all of k. This is a bit confusing, I guess, but that is what we're supposed to do. So we have to print one value for here. So we have to find the answer and print it. Okay, so let's say int answer equals into the power 9. Did it say what to do in case you cannot? Okay, I guess it's always possible then. It's probably provable, but I'm too lazy to prove that. So see, for k can go from 0 to n. The answer is the minimum of what a currency is, and n minus 1 jk. So for all possible values of the last number, we're keeping that into account when we're printing the answer. Okay, let's run this. Just gonna copy the input. Let's compare that with the answer. Oh, this is not right. Okay, let's see. The 4, 3, 2, 1, 2 is right. The first one is not 4. Okay, let's see what they have. 0, 1, 2, 3, 4. 4 and 3 is different. That looks about right. Okay, so I'm just gonna go ahead and print all the values in the log. In the DP array. So and I'll see if I can find the one that is incorrect. Actually, I'm gonna print this for I plus 1 so that the day starts at day equals 1. It's just easier for me to visualize. That's just one of the defined I normally use. Sorry. Oh yeah, I need to put this at the end because we set it while doing the loop. Oh. Can I not copy it? Okay. Let's look. If we make the first letter 0, here's an example. If we make the first letter 0, then so it's not possible to get only one breakout because the first one has to be a breakout, so the second one, yeah, this looks impossible. This one looks good because you cannot have only one breakout when the second one is 0. Second one is 1, you can have one breakout, and we're only changing the first one, so that looks about right. Second one's 2. You'd actually want to redo this without printing all the ones that are above infinity, because that's just getting annoying to look through all those. Oh. Okay, if the first one is a 1, then yes, that's exactly one change. If it's anything else, then oh, you know what I'm thinking? I just realized there's a bug in the code. If the current value is 0, yes, the previous value can be any value of k2 from 0 to n. But if the current value, if we're not starting a new breakout, the previous value must be from k minus 1 because it increases by 1 from the previous day. Okay, let's try this. Now let's look at this. 4, 2, 1, 2, 3, 4. Okay, this looks about right. I'm just going to add the file input output. Let's build this just to make sure there's no bugs. Cool. And that was test 9. Oh, I forgot to comment out all the print statements. That was really silly of me. and I got it. That's great. Hope this video helped you. I hope it was more useful than the videos where I just make solutions. And bye.